Welcome, and thanks for joining us. My guests today are Kurt Smith, Vice President and GPU Data Center Architect for Accelerated Compute Product Group at NVIDIA, and Mike Weissman, Vice President of the Americas for Public Sector at Pure Storage. Gentlemen, thanks for taking the time to be speaking with me here. A lot going on in the federal space when it comes to AI, and I think that's just a great way to frame the rest of the conversation going forward here. What types of problems do you see being solved with AI in the federal space? A big value proposition there. Let's hear more on that.
Thank you, Jory. Yeah, I'm often asked what can be solved with AI as it relates to the federal space. And I think it comes down to two things. AI automates or predicts. This is obviously going to drive many downstream applications. And in reality, the application of an organization's data is endless. So with each new insight producing opportunities to fuse additional data points into collective applications. With that said, I'm more interested in the modality of the data and having an end-to-end AI stack that can quickly abstract an organization's data and extract value from it. I think once you develop the data-driven pipeline that processes image data, for example, it becomes a function of training the data and time. As an example, teaching an application to identify various forms of battle damage is not terribly different from identifying common types of corrosion found on maritime assets or in other harsh environments. The key thing to focus on is really around accelerating the time to insight through the development and training of acceleration. And that's where the GPUs and Flash really shine and should be a part of any AI-ready reference architecture.
I guess I would add only that in terms of the agencies and the members of the branches that I've talked to, their excitement around AI often focuses on how it impacts the decision loops in real time in terms of improving their ability to orient, identify, and classify the information in this multi-sensor fused data environment and to improve the signal to noise ratio for someone who needs to make a decision in real time. That is a hard problem. And in the tactical side, it sounds really simple. Behind that, though, it needs to be recognized in each of these organizations that they have a big AI model training task to undertake, and that's going to take a fair amount of compute, a lot of storage, fast networking, and a commitment from the organization to drive through projects where they're experimenting, putting AI into their products, and creating a culture that believes in the power of large AI to solve these kinds of problems.
Great. Well, I think we really hit on the key points in terms of, the value proposition, the opportunities for agencies in this AI space. I think to change gears here a little bit, I think it would be worthwhile to recognize the kinds of capital investments agencies would need to take to make this succeed. Kurt, we'll stick with you for now, and then we'll move back to Mike. When does it make sense for an organization to consider the expense of utilizing AI to solve a problem?
So I think it comes down to when they've realized that they have problems that are in an area where, over the last few years, we have seen the success of AI in terms of things like image classification, text and document processing, natural language processing, where AI, when it's being used to solve those types of problems or to create systems that can process that kind of data, what we see is it can't be done with normal algorithmic approaches. So if those are the problem spaces where basically the people in the field, the analysts, or whoever the users of the systems are, they need to be processing text, language, images, and then in joint all domain operations, now we're adding in cyber ISR with electro-optical, perhaps spectrum, radio, all of that fused and done in a way that can be processed holistically, then they need to consider an investment in AI infrastructure.
Got it. And Mike, over to you. Any thoughts there in that space?
Again, as it relates back to the expense, it really depends. I don't think every problem will benefit from leveraging AI. Sometimes the economics may not make sense. In the end, I think having a robust organizational data strategy is probably the most key item to focus on. You have to have a data-centric organization from a cultural perspective that wants to repeatedly extract value from that data. So people play a huge part in this. So the people, process, the platforms and tools need to be aligned in the pursuit of gaining value from that data. I think the good news here from an economics perspective is that the cost associated with the hardware and software required to make AI initiatives successful has decreased. So that, coupled with the fact that obviously AI functions 24/7, and combined with the availability of affordable GPUs and flash storage, it's made a viable option in lieu of staffing for those activities. Most AI initiatives are focused on the need to accelerate time to insight and reducing the cost of curiosity. And I think that really plays well in this environment. Once you build out an agile infrastructure and cultivate the access to the organization's data, you'll be able to develop intelligent applications and augment intelligence and optimize the business processes. Building out the computer vision and workflow to identify the markings on tactical vehicles is not all that different from building a workflow to identify a shipping container or rail card markings at a freight terminal. Both are utilizing optical character recognition and natural language processing. What changes is the massive amounts of unique training data required. The infrastructure, know-how models, and algorithms generally stay the same. Jordy, I think the short answer is anytime the agency has significant amounts of data and wide-reaching problem statements, they should review their data strategy and find a repeatable process that they can benefit from through an automated and predictive workflow powered by AI.
Got it. Thanks for that, Mike. And, I want to keep going on this thread here and pull it a little bit more. Can you talk more about the importance of having sufficient compute resources? That's going to be huge to enable this AI in agencies, both in terms of CPUs and GPUs in AI workloads. Mike, we can stay with you if you'd like.
I think this is a complementary conversation. They work great by themselves, but better together. So it's a better together scenario. When we think about the massive amounts of computational workloads that go into the training of production AI, we're thankful for the game-changing parallel compute power of NVIDIA GPUs as an example. That said, GPUs need data to process. If you're not feeding the GPU at the high end of its processing power, you're slowing down your AI project and devaluing the GPU. Both lead to losses in time and a loss in your return on investment. Having a unified fast file and object strategy to keep the GPUs fed is critical, and this is where flash shines. There are other benefits of flash storage centered around high-speed ingest of sensor, IoT, and other third-party data that needs to be considered. But the goal is to have the design and deployment to be most agile and resilient GPU and flash architecture enable the AI development with a reasonable and productive timeline for the organization. In the end, data changes rapidly. You need to have an architecture that can abstract the data before it's outdated. I'd send it over to Kurt for some more commentary on that, but I think the combination of the high throughput and the addition of large capacity really equals a great combination for flash storage for maximum efficiencies.
So one of the things we've seen in the last few years has been a roughly doubling of the complexity of large AI models every few months. And so what that has been driving is the number of GPUs that are needed to train a model in a reasonable amount of time. So if you look at some of the latest language models, it's not uncommon to see a cluster size of over 10,000 GPUs in a single cluster to train a large language model. That's the state of the art. And then you have the same associated rise in the amount of data that's required in order to, put together a large corpus of language in order to train on. So, we're seeing this kind of exponential explosion in the amount of compute and storage needed to be at the state of the art for many of the model types. So that's kind of where I would add.
All right, great. Thanks for that, Kurt. And I think to keep going down on this architecture piece, it's huge to any kind of AI success and any kind of agency here. But, looking through the eyes of agency data scientists, how should they be concerned about things like AI pod architectures, really, getting to that hardware and software stack? What should they know and what should they be considered? What should they be concerned about in terms of all of that as it involves an AI strategy to solve a problem?
The data scientists play a huge role in this. So the role of the data scientist is to define the process that's going to create the AI that performs with a high degree of accuracy and confidence. But in order to have a computer system to actually execute the tasks, there's a data science model that must be developed, which requires programming so the computer can learn what to do. We call these deep learning algorithms. Developing production grade AI is a challenging process with several nuances. You have to incorporate data strategy, data engineering, development and testing, deployment, and sustainment into a well thought out initiative. Not considering AI infrastructure through this process introduces risk and could derail or delay a project. So leveraging a scalable, resilient, agile, and agnostic AI pod architecture helps to mitigate false starts. You need to have an easy to use turnkey AI technical stack, which will allow data practitioners to focus on the data and the problem statement, and ultimately reduce the cost of curiosity and accelerating the time to insight for the organization, which really comes down to more science and less administration. The basis for these learning models are large neural networks composed of many computational layers, hence the term deep. This allows deep learning algorithms to solve complex problems on diverse unstructured data sets. The more a deep learning algorithm learns, the better it performs.
Well, Mike, thanks for that. I think we're going to have to get to the deep learning part of the conversation after the break here. My guests today are Kurt Smith, the Vice President and GPU Data Center Architect for Accelerated Compute Product Group at NVIDIA, and Mike Weissman, the Vice President of Americas for Public Sector at Pure Storage. I'm your moderator, Jory Heckman, on the discussion, infrastructure considerations in your missions AI strategy.